Mr. Sharma. Chetan sir, have you joined that?
Yeah, hi sir. Good afternoon. Yes, I am in.
Yeah, very good afternoon. So, on behalf of Dr. Grupage, the faculty, this coordinator of the faculty development program, I, Dr. Narendra Sharma, feel privileged to introduce the speaker of the day, Mr. Chetan Sharma. He is a senior design quality engineer at Tata Consultancy Services, working for Johnson and Johnson's Meditech. He has done BTech Mechanical Engineering and Master in Business Administrations in Operation Management. Our expert, Mr. Chetan Sharma, has more than 10 years of the vast experience in design and development of automobile and medical devices. He has also worked for American and Japanese OEMs like Ford and Honda, and also successfully delivered engine part to Ford Motor Corp from prototype to production. He is a passionate about different manufacturing processes and design tools. I extend my warm welcome to Mr. Chetan and invite him to share all of us with his knowledge on additive manufacturing. Chetan sir, kindly join us.
Okay, thank you so much, sir, for this great introduction. So I really want to thank everyone for joining today this online session. Am I loud and clear, sir?
Yeah, Chetan sir, you are very much clear. Kindly share your PPT, please.
Yes. Just give me a second. Okay, just let me know when you guys can see my screen. Perfect. I
Yeah,
think
it's visible, sir.
I'm in. Okay. So really want to thank everyone for joining today this online session. I really appreciate you taking time to be here and excited about the discussion we're gonna have today. Also want to thank Narinder sir, who is the Dean R&D, and also Gurbed sir, who is the coordinator of the faculty development program. So thank you everyone. Okay, so let's start with today's topic, which is the quality control, the testing and certifications of the additive manufacturing and the advanced manufacturing parts, right? So before starting over it, I just wanted to tell you guys my experience and the different industries that I've worked for, and there itself in those industries I was able to have a knowledge about this additive manufacturing processes. So I worked for automotive company, as I said, also the medical device pioneer industry for American companies like Johnson Johnson's, and in automobile sector, which is Ford Motor Company, and Japanese companies like Honda. So I was into R&D for all the time, and was able to deliver multiple products, the actual products starting from the scratch, which we call the brainstorming and the search, to the final production. Okay, so let's start with the topic. So I'm sure that you guys might have earlier discussed about the additive manufacturing a lot during this a week sessions, which will be taking over by different experts on this topic. But still, as a part of my job, I would like to just put some light on this additive manufacturing again, just to create a base for my topic, which is the quality control, testing, and the certifications of the additive manufacturing parts. Okay, so I have categorized this manufacturing processes into main streams. One I would call it as a traditional manufacturing processes. The other one I have called as a, the additive manufacturing processes. So traditional is very broad. So which we have been using the industry in the automotive sector, or either in the medical devices, aerospace, defense. So all these industries which are currently working on creating technologies for us as a part or the physical parts. So they are using these manufacturing processes, right? So there are certain examples like machining. We are dealing with a lot during the industry work. Then we have casting process, we have forging process, we have rolling process and the welding process. A lot more processes traditionally we've been using ever since, like till date. So we're still using it, and we're gonna use it in coming future also. So these are the these are the traditional manufacturing processes. The other one is the additive manufacturing. So like from past, I would say 5, 10, 15 years, or maybe not more than 15 years or 20 years, this additive manufacturing is been discussed by uh, the big industries, big companies a lot. Even though if you will search on the Google regarding the manufacturing processes, you're gonna have a lot regarding the additive manufacturing. It's a very hyped technology that has been immense right now, and has a great impact on our current needs, our industry's needs, and our quality of the products need. So additive manufacturing overall includes the it's a material extrusion process, I would say. Extrusion process, I'll explain it as a addition of the material, maybe, right? So it's these are all the like, additive manufacturing. These are all the examples that I have captured here for you guys. So different additive manufacturing, for example, material extrusion, powder bed fusion is a good technique. Medical device industry uses a lot uh, this technique, this powder bed fusion technique for the additive manufacturing. They use a lot for their products. And we have DT, we have sheet laminations, binder jetting. These are all the process we're gonna discuss a little more about in our coming slides. And yes, so we'll have I'll deliver this PPT, and we're gonna have a small Q&A session also after at the end of this session, maybe, right? So just feel free to in between also, if you guys have any questions, just feel free to interrupt. I don't mind, and we can answer that question as well. Okay. So yes, so what the additive manufacturing is, everyone is talking about it. It's very hyped technology. It's very interesting technology, I would say. Like I myself has personally got bored, like talking about or listening about the traditional techniques or the traditional manufacturing processes, which is casting, machining, forging, welding. Everyone knows about it, but it's additive manufacturing is very interesting. So we'll have more details coming forward. So what the additive manufacturing is, somebody call it as a it's a 3D printing technique, the process that uses advanced materials to create physical objects from 3D digital models, right? So what 3D digital model, I would say this techniques use CAD model, 3D digital model, specifically, I would say is a CAD model. And that CAD model is being prototyped or printed in a 3D manner, right? So, so it's it's as simple as that. You go to your the stationery shop and tell the shopkeeper to print this file, right? He gives you 2D printer, 2D printing. right, of the on the page. It's as simple as that. You tell the machine, give him the CAD drawing or the CAD model, STL file, and it will give you the 3D printing part. That's cool, right? Yes, that's very interesting, but it's not as simple as I'm talking about as a printing on a paper, but it's way more complicated than we are thinking right now. Okay, so what it does, it additive manufacturing used to create complex structures, right? Now, this is the main reason that it been introduced. It's one of the pioneer reason this additive manufacturing is now very is in the hype right now, and everybody is talking about it, right? And has many potential applications. So it's rapid manufacturing. The part is produced by printing multi layers, and so I'm sure this will work. Just give me a second. Okay, so it's just like this. So a machine, a jet with the material will pour layer by layer over the previous layer, and it will create a 3D model as a final product for you, right? So this is the basic, very less about what the additive manufacturing is. I really hope, because I really hope you guys have much more idea than me regarding what the like additive manufacturing is or the 3D printing is. So basic materials that we use: the powder-based material, semi-molten material, ink-based material. So if somebody would ask, "Hey, these are not the materials," yes, exactly, these are not the materials. But yeah, these are the forms in which the materials which gonna be getting printed, right? Material are um, as basic as we normally use, which are like, for example, metals, alloys, and I can remember this is a very important alloy. This is a titanium alloy, which is very famous in the medical industries, which is being used in the additive manufacturing process to create the parts, right? Okay, so yes, so this is a why additive manufacturing we need, and why it's a future actually. So why is a big question. So let's discuss something about why we need additive manufacturing and why it's a future, like everybody calls it. Customization, customize outcome, right? That's interesting. Okay, change of ability, no size, no fit. Okay, everybody wants basically the people who don't have ability to walk, or they need something for the support, so they need the product to be as fit as their body, right? So yeah, additive manufacturing solves this problem. So you can see this second picture over here. So 3D printed seats, you can print the seat based on the size, shape of the body of a particular person. So it can be a man or an animal or anything, right? Design freedom, low volume manufacturing. So these are the futures. So design. So this might be looking funny to you guys. Like, why would anybody invest so much on this, like these type of design? So I would rather not consider this type of chair for myself and getting created in additive manufacturing, which it's very costly too, right? But yeah, main future is with the medical industry and the aerospace industry. Right. So additive manufacturing is crucial in both the medical devices and the aerospace industry due to its ability to create complex design, customizable part with high precision, leading to significant advantage like lightweight design, reduced material waste, faster prototyping, and potentially for high personalized medical devices. Yes, great. So additive manufacturing has a great future in the medical industry and the aerospace industry. Why so? Because of its ability to create complex designs. It can create less weight design with high strength, and which is why it is very important. So I have put it down here as an example is regarding the medical devices specifically. So patient specific implants in the prosthetics. So individual patient and anatomy as an uh, based on the body's requirement, body shape, body size, and the fits. You can create 3D printed models and use in the actual body, leading to improved fit function compared to the traditional standardized options. Right. So this picture you see at the right is a hip joint, and I think I had a project previously with Stryker and Boston Scientific. So these are the leading manufacturers of the medical implants, specifically orthopedic implants. So this you see picture as it's a hip joint, and it's been manufactured. To be very frank and to be very true, it's been manufactured by 3D printing, right? Surgical planning and training model. So it's very easy for doc for the manufacturers to create 3D models which can be used by the learning doctors to operate, or maybe pre-operative conditions to understand, enhancing surgical outcomes. Right. So next, in the aerospace industry, we have a lot more use in the aerospace industry. Why it is been used in the aerospace industries and is very famous in the aerospace industries just because of its lightweight and high strength components. Additive manufacturing parts enables the creation of complex lightweight structure with high strength to weight ratio by utilizing latex design is the complex design, whatever you want, leading to improved fuel efficiency in the aircrafts. You know, in the aerospace industry, weight is very important. Like every kg is put on and decrease the efficiency, right? More the weight, less the efficiency. More the weight, more fuel would be getting generated. More the weight, more fuel, and more pollution would be done, right? So it's a game changer. And in the aerospace industry or in the traditional defense industry or anywhere, so weight is very important. So you really don't want to send rockets to Mars or the moon with a lot of weight, and you don't have that size to, and for that you would need more fuel and more wastage, right? So it's a game changer. Okay, so reduce part counts and assembly time. Just I'll give an example. So let's take an example of of a lock. So we have everybody has a lock at their home, right? So from outside you'll see just a single assembly. You just press the top of the lock, turn the key, and it's getting locked, right? But when you open that lock, it has multiple assemblies and the sub assemblies which are joined together and to create that assembly, like final assembly and the final product as a lock, right? So this 3D printing saves a lot of time and the cost by creating a single piece. You don't want multiple assemblies. You can create a single assembly and a single part with 3D manufacturing or the 3D printing, right? By integrating multiple components in a single piece, additive manufacturing can significantly reduce the number of parts required. And it's also save time. How would it would save time? See, time and costs are very important for the industries. It will take time to assemble all those parts. For example, I gave as a lock. You will need the resources who would assemble it. You will need the processes by which you're gonna assemble those parts. Why would be worry about all these problems when you're having this 3D printing as a future and creating a single part in a one go and you can use it, right? Okay, rapid prototyping and design iterations. Okay, yeah. Additive manufacturing allow quick production of the prototypes. Yeah, prototypes, enabling rapid design, iterations, and testing. Right. So you can let's take an example. I create a prototype. I'm working for a R&D project, and I have to start from the scratch. I did the market research. I design a part. So rather than going to the traditional way, molding it, casting it, forging it, why would I not go to 3D printing? Get it print, test my part, it's not working, change my dimensions in the CAD, reprint it, then reassemble it, test it, then again if it's not working, then use it, then create the final assembly in some, maybe in a large load. You create the molding machine, you like order the molding machine and start creating part. But for prototyping, it's very very important, it's very useful. So I remember when I was working for the Ford, and so we designed a automotive part which was a solenoid valve, and we get in a very big trouble when we send the part to Ford, and from the Ford they send us back some other company's part, and it was basically a China part who was designing same as what we have designed. So, and they have filed patents and everything over the period of time when we were like designing. So it was a situation where we had to recall that part because it was breaching the patent economies, and due to that, the Ford came back to us and this told us, "Hey, create the part within a month." I don't know how. At that time, this 3D printing was a miracle. We printed the part overnight, we used the part, we tested, reprinted it, retested it, reprinted it, retested it, and at the end we were having the new design which with having same performance, same specification as we delivered previously to the Ford. So it's a game changer. That's why I would say it's the future of the manufacturing industry. Okay, so this was all about the additive manufacturing process, their future, why it is so much important, why everybody is talking about it, why it's in very hype. But since we already have started working on these processes, have already industries have won like they have dealt with it, they have gone through a lot, and they are on a very good stage now. So quality control is very very important for additive manufacturing part. Not for additive manufacturing part, I would say it's important for other industries also, other like traditional manufacturing ever since. But you know, traditional manufacturing, we know everything about traditional manufacturing. We know how to find the defects, we know how to control the quality of that product, how to stop, where to stop, how, when to stop. It's very important. And we know about the traditional industries because we've been working with traditional manufacturing processes from long back. We know everything about it. So we have found out the loops, we completed and filled the voids in the traditional manufacturing processes. But what about additive manufacturing process and his quality control? Okay, let's go on. Okay, again, why we need quality control for additive manufacturing part? See, the major application nowadays, like till date, we have in the medical industry and aerospace industry and the defense industry also. So that's why I'm like more of focused on these industries, and I'm not talking about automotives, right? Because automotives has a mass production to deliver, right? So they are not ready for this additive manufacturing right now. But yeah, coming future, definitely this new designs, because I was seeing this video on a YouTube previously when I was discussing about this additive manufacturing, and I saw Boeing uh, as a company, US company, was manufacturing uh, parts for like interior parts, interior products, interior parts of a car to BMW. Yes, so they have come up. So additive manufacturing has already been in this field, but it's not as that as in the medical domain, the aerospace and the defense industry. Okay, so Quality control is paramount in additive manufacturing, particularly when it serves as a production technology. When we are catering the multiple production levels, we are catering the mass production. Unlike traditional industry or the traditional manufacturing methods, where defects can often be visually detected and corrected, additive manufacturing operates on a layer by layer basis, making it imperative to catch errors early in the process, right? So it's a plus point for manufacturing, traditional manufacturing processes that, as I said, we have gone through a lot in the traditional manufacturing, and we have founded a lot of methods, techniques for the quality control of the additive manufacturing. But yeah, yet to do for additive manufacturing. So that's why it's very important, and it's very difficult for additive manufacturing. So defects are not visually detected. That's a very big problem in additive manufacturing or the 3D printing, since it operates layer by layer. You know, like as I saw show you the video, additive manufacturing works on the layer by layer processes, and we cannot just see what's happening inside the part. You can see outside the part, but it's very difficult for anyone to see what's happening inside, what all effects it has, what all discrepancies a part is having come inside. It's so difficult to catch error early and easily in the process. That's why we need it, right? Industries such as aerospace, marine, medical device, where precision and reliability are, excuse me, are not negotiable. The consequences of inadequate quality can be catastrophical. Catastrophical as in it can kill somebody. If you will manufacture a medical device which is not as per the quality, definitely gonna kill somebody, right? And it's as difficult, or it's as risky as ranging from equipment failure to patient harm, patient death, I would say. Okay. Any deviations in material property, printing calibration results in defective products, compromising functionality in some cases, and even possessing safety risks. So that is why it is very important. See, nobody, no company, no industry, no regulatories want anybody to risk human life or even like animals' life. So it is very important for us to put impact and understand the quality control of the additive manufacturing. Okay, so what are the concerns that we have regarding the quality control of the additive manufacturing? So we have a lot of concerns, as we already discussed why we need it. So now, what are the concerns that additive manufacturing quality is difficult or risky or whatever it is? So quality control in the manufacturing parts is critical due to several key issues that we can significantly impact end user functionality. End user can be anybody. End user can be human. End user can be a machine itself. So it can be anybody. So we have several key factors that significantly impact the end user. Firstly, dimensional accuracy. So the major concern is we need the dimensional accuracy in wrapping our common challenges. Variation in the temperature. So this slide basically tells you about, I would say, not challenges, but what are the concerns that we have dealing with the additive manufacturing, right? So let's say a company is purely working on this manufacturing technique. What are his concerns? Why they need the quality control, right? Because dimension accuracy is very important for them for their product, and it's very difficult for somebody to capture in the additive manufacturing. We have a lot of variations in the temperature, cooling rate. See, there are multiple additive manufacturing where this hot nozzle is used to pop the molten material. Due to that, we have a lot of variation in the temperature, cooling rate, and part geometry even can lead to wrapping and distortion during the printing process. So that's a very big concern for industries to deal with this situation where they have a lot of variation in the temperature, cooling rates, and distortion in the printing process, right? The quality and consistency of the material used in the additive manufacturing varies a lot. Yes, this is very true. You know what? At like during our time also, when I was like working on that Ford project with this additive manufacturing product, so this was a big concern where one part you'll manufacture or you will print would definitely have variation with the second lot of part you're gonna build in coming future. So that's a big concern, which definitely gonna affect the mechanical, thermal, and chemical property of the part. So consistency is very important. So this is a big concern for industries like medical device and the aerospace industry, where they want the consistency in the part. Like you don't want variations in the part. Let's say you manufactured a hip joint, right? And I would say it's been manufactured for specific patient. But let's say if you have to manufacture the mass production of that hip joint, you cannot just take up uh, like differences in the shape, in the sizes, and the material and the property of the same part, but manufactured at different time with the 3D printing. Right? You don't want it. Industries don't want it because it wastes lot of time, lot of money, and everything. The research, everything. Right? Layer addition is a crucial concern, especially with technology such as fuse deposition model. This addition, as in, I would say it's create weak bonds, reducing overall part strength and durability. So these are the like major concerns in our quality, uh, like with dealing with the additive manufacturing, and that's why we need quality control for these this kind of manufacturing process of the additive manufacturing process. I'm sure I'm not that fast because I wanted to like cover everything. So I have like lot more slide coming forward. So just let me know if you guys not able to understand whatever I'm saying, or you want me to be more slow or more fast. So just don't hesitate to interrupt in between. So now we have discussed about what are the concerns in the additive manufacturing. So we have discussed about why we need the quality control, but how are we gonna do the quality control? It's a big question, right? So have captured or have written down a few points on this subtopic, which is quality control for additive manufacturing, and how we gonna do it in the real time in the situation where the industries are manufacturing, right? So ensuring the quality of additive manufacturing parts or the advanced parts require a combination of techniques and strategies to address various aspects of the printing process, right? So, so I would say not only quality control of the part, it's overall of the whole manufacturing process, right? Which includes parts also, which include the machine or the printer, which is eventually printing the parts for us. So the quality control of that also is very important, right? So for that we need combination of techniques and strategies to address these aspects of process printing. Yes, calibration of system. That's what I'm talking about. So 3D printer, like everybody talks about, okay, the part is of this size, the part is having the specification as the strength as the as per the specification. So everybody has tested that your product is good. But what about the generic? What about the creator of that part, which is the 3D printer? So we need calibration of that system being used in the fundamentals to achieve precise and consistent result. So this consistency, which I was previously discussing in the last slide, that industries need consistency in their part, can be met by calibration and different techniques in the for the like different techniques to be used on the printer. Okay, regularly calibration and maintaining the 3D printer ensures that it operates within the specified tolerance, right? So now I'm not discussing yet about the parts, how we're gonna test the parts, how we're gonna control the parts. But first of all, we have to deal with the printer, which gonna print it. Let's say I give a CAD to a printer. If it's not calibrated, it's not give the final product as you need it, right? Because it's not calibrated, it's not been verified by the industries as per the regulations, or it's not been timely maintained, right? So we have to put our quality, we have to assure the quality assurance from the scratch, from the base itself. So printer comes in the first chapter. Then again, how we going to control the additive manufacturing and the concerns of the, and how I would say, how would we addressing those concerns that we had in the previous slides, is by choosing the right material, right? So this part, if you see over here, and this part, which is to be used or which has been used for the aerospace industries, do you think these two parts would be manufactured with the same material? No, right? Because different processes, different designs, different requirements has their own material requirement, material needs, right? So choosing the right material is a crucial for achieving the desired mechanical and the thermal property in the part and the desired product that we need after the additive manufacturing. Okay, so so the material is right, the printer is correct, material we chose is right by doing the R&D. What next? We printed the part. After printing, post-processing steps like surface smoothing, support removal for some additive manufacturing parts, powder removal for processes like SLS, and the heat treatment can improve the final product aesthetics and the mechanical property. Right. 3D printer is right, and now the material we chose is right. We created a good part, good as in like visually I saw it's a good part, but still the internal mechanical properties can be there in the part. So for that, we're going to use multiple processes. This, for example, I told you these are the post-processing processes that we're going to use to control the quality of the additive manufacture. Okay, now let's say everything is done. Now, what next? It is very crucial for a company or for a manufacturer who's dealing with the additive manufacturing to maintain the records, document whatever you are doing. Records as in you should be having appropriate printing settings. Like let's say in today's time, like if uh, in the morning I manufactured a part with certain printing setting, you should be having noted down that setting before closing that printer, so that in the next shift, in the afternoon shift, when somebody would gonna use it, should put the same setting as prior. Very important. What material batches that has been used, and what were the inspection results that is being used during that morning session or the morning manufacturing time period. And you need a record of all of these. And you know that nowadays industries has gone so far, paper record is not applicable at all. especially in the medical industry and the aerospace industry. We don't use, as a design engineer, design quality engineer in the medical domain, we don't use paper. We have certain PLM system, and PLM system is product where we put in our old documents and the records as a whole, so that it is been visible, it is been captured by all the departments, either it's from R&D, or it's from quality, or it's from sales, purchasing, incoming inspection. Everybody can access that. So documentation is very important. Documentation is done, everything is done. What next? So quality control is not just for the current product that we are doing, or the current processes that we are using, different processes in the additive manufacturing itself that we are using it, but continuous improvement in the techniques is also very important. Continuous improvement is also essential when assessing the quality of the additive manufacturing. Why we need the continuous improvement? See, this additive manufacturing is a growing industry. This technique is growing. There are lot to come, there are lot to learn, and there are lot to be researched and scientifically proven, right? So day by day, rapidly it's evolving, right? Advancement are coming in the material, advancements are coming in the processes, advancements are coming in the capability. So continuous improvement and knowledge of that, and being up to date regarding the same, is very important for a medical or for an industry which is using the additive manufacturing processes and dealing with the advanced parts basically. So these are all the quality control. Okay, so we discussed about why we need it, what are the concerns that we had during our during dealing with the additive manufacturing. Then we also discussed how we're going to do it. We looked at different overall processes or overall thought process, I would say, how a company has to understand, a company has to be get in touch with these kind of scenarios where they just don't have to look at the part itself, but they have to look at the overall process of the manufacturing to control the quality of that manufacturing process, or the advanced part, right? Okay, so we discussed these are the quality things, but now what are the techniques and what are the testing methods that we have with us regarding our additive manufacturing parts and the additive manufacturing processes? Okay, so first of all, testing of additive manufacturing typically involves both destructive and non-destructive methods to evaluate the quality of the product, uh, including the followings. Right. So the slide basically shows you what all defects that we can have in our additive manufacturing. And coming forward, we're gonna discuss in the coming slides how we're gonna test these kind of defects. So on my right, I have this image as A image and a B image. These are some kind of common defects that we see in our additive manufacturing, which is poor bonding defects, that two materials are not getting bonded, or maybe two layers are not getting bonded. Right? Not only materials, two layers are not getting bonded. Maybe at some situation, at some time during the printing of the part, there would be some unmelted material, or the metal particles, or the powder, which being there present in the inside of the part, right? Not on the surface but inside. Who knows what's inside it, right? So testing, why we need it? We need the testing of the additive manufacturing is to test the internal defects, like internal cracks, and if there is a bonding happened for that particular part or not, right? Then we need testing to check the dimensional accuracy. We need these testing to check the mechanical properties of the residual stress and the porosity, and of course, surface finish, right? So this image just below my cursor is an image which reflects the discrepancy in the mechanical property of the additive manufacturing part, right? So we need the surface finish for these kind of a product. So this aerospace product of the coupling assembly. So we need the finishing of that part too. Then testing of additive manufacturing. So we have discussed why we even need testing of additive manufacturing part. So now we're gonna put some light on how we gonna do the testing. And yes, I wanna say this to everybody: dealing with or working with additive manufacturing is not that easy with respect to the availability of the technology that we have, and also a big factor which plays a role is the cost, because cost is too much for using this additive manufacturing right now. But yeah, once we'll have advancements in the techniques, we'll have researches, we'll find new methods of testing, we'll find the new methods of additive manufacturing processes, so the cost would get reduced timely. And also now, for this time, we don't have that capacity to do the mass production of those, and it takes a lot of time as compared to the automotive industry. So that's why it's also where we deal with the less quantity, always cost increases. When we are doing the mass production, the cost decreases. So this also a factor here. Okay, so we were talking about the testings, how we're gonna test it. So this is a very cool picture, and this picture is taken by myself, and this is a X-ray machine. So unlike, like, if somebody would have seen the X-ray in the hospitals, you also have X-ray machines in the industries also, right? So you do the X-ray, and these are like two uh, parts. These images I have captured, and I have like uh, get like I got these images from one of my colleague, like he was working on this kind of a parts. So X-ray CT scan machine considered the most comprehensive NDT is a non-destructive testing method, providing detailed internal 3D imaging to detect porosity, cracks, and other internal defects. And not only internal defects. You see this image. Why is this image I have put it here is, you can even check the dimensions. But yeah, to be very frank, you cannot just have the very precise dimensioning. But yes, you can have the idea, and it's very useful. CT scan is a game changer in the industry, and it's very expensive. So in my industry, when I was working with Padmini, when I get to see this machine, and it was like freshly bought during my tenure only, and it was, I guess, uh, and I'm talking about 2016, and this machine cost approximately 3 crores. So it's way too much for a new industry. So this is one of the method where you can check the internal defects, check what inside it, how the part has been manufactured. But it's a expensive method, but company uses it. Like, who has capability and money for industry or application for using additive manufacturing? So it's required, and it's easy for them uh, to purchase this kind of a machine for their quality system. It's important for them to manufacture it. So okay, other non-destructive testing that we have is the ultrasonic testing. An ultrasonic testing machine is used to detect internal flows and defects in the materials, like cracks, voids. How we do it? So it's been done by sending high frequency sound waves, ultrasonic waves through the object, and then analyzing it by reflecting the, like, it basically is reflect the signal back to the receiver, and you get the data on it. So I have never used it, but yeah, but it's a very cool machine too. It's cool technique to check the additive manufacturing and do the testing of that. So we can check the thickness, internal damaging, and without any destruction of the part. Right. Visual inspection, everybody knows about it. So basically, you check the product from your naked eyes, and you see what are the defects, and you can even check the dimension visually. And all these are the, like, the non-destructive testing that we do for the additive manufacturing. Dye penetration technique is common in, not common in medical industry, but it's common in the aerospace industry. And this is not this testing, actually, I would not say is reliable, much of it, and we don't use it in our production parts. Yes, during our researches, during our R&D process, we use this dye penetration inspection a lot, because while dealing with R&D stuff, you won't be having everything with you to uh, create a product, right? You have to search economical techniques to inspect the part or deal with the product. We have testings which are destructive. So this is kind of same as we use for our traditional manufacturing processes, right? So we have tensile tests that we do for testing the tensile strength of the part. We use compression test for checking the compression of the part. Fatigue, sharp impact test. This is a photograph of sharp impact test where we check the ability of a part to absorb the like the ability for absorb the energy during the impact, right? So this person, this inspector is maybe somehow testing the additive part with this sharp impact test method. Okay, so these were the techniques or the testing methods that we use for for the additive manufacturing. Now we have, what are the factors which eventually influence our manufacturing testings, right? Material type plays a lot more role in this type of technique. So different material like polymers, metal, ceramic have different testing requirements due to variation in mechanical properties. So while starting off with a technique, it's very important to understand what the material is and what the requirement for testing is. And based on that material and requirement, you have to design your test protocols. It's not like you can use the this UTM machine for every material, right? So why I'm saying this machine that you can see on the screen, this cannot be used for checking the plastic parts, right? Or rubber parts. So testing methods also depend on the material type. Then you have next up with us is additive manufacturing processes. What are the processes that we are dealing with? Might be depending on how we're going to test it. The specific additive manufacturing techniques that we use, example powder bed fusion or material extrusion, can influence the type of defect. So process you are using that can create multiple defects on the same time for the same test, for the same defects, you're going to have to check what all the testing that you're going to need it. Application requirements. So what all testing the specification that are necessary for your test. Like if you say, if I will say you need a geometrical testing, you will not use a fatigue test, or you will not do a tensile strength test, right? Geometrical testing can be done by the Vernier caliper or the height gauge or other instruments, right? So application or the specification of that or the requirement of the test is also plays a vital role during our testing. Challenges that we deal during our additive manufacturing testing is the complex geometry. Yeah, this is a big challenge, because see, we are why we are using additive manufacturing is to counter the requirement for complex geometries that we need, complex designs that we need. So that's a problem for us to test the parts. So this design possible with the additive manufacturer can make traditional inspection method difficult. So you cannot just use vernier caliper height gauge to check those parts. You have to use those X-ray machines or the CMM machines to check this kind of a geometry. Other thing is you have a layer by layer technique, so you have a layer by layer defect. Identify defect within individual layer of printing, or the part the layer has been printed, is challenging. So we need high resolution entity techniques, X-ray machine of high resolution, right? Which can even penetrate through titanium alloys. Right? That's how you're gonna test it. If you're using techniques like ultrasonic testing, so you must be having high intensity ultrasonic testing machines to get penetrated through like to the surface of the body, and you can get the testing. Surface structure, inherent surface roughness of additive manufacturing part can be very complicated to test the surface inspection of the part. And for that, we need multiple testers, hardness tester, surface roughness tester, and of that, and those testers also of very high grade. So these are the challenges. And see, if we are have you need high grade, high resolution entity machines, high resolution techniques. Eventually, you are dealing with high cost, right? So that's why additive manufacturing everybody calls is a high technology, because it's very expensive. And medical industry, that's how medical industry or the aerospace industry is very expensive, right? Because it deals with complex parts and complex techniques and the complex testing methods, and for these type of techniques you need skilled people also. Okay, so the last topic that I'm going to discuss, it's not much of it, but since we have discussed about quality, then regulations and certifications also comes in chapter a lot. So we make a few major changes in the manufacturing processes that we need specific consideration for the certification process. So as I joined a session early, and I was listening to the previous expert, and he was saying something about the regulation. So he was very true. So regulations are very important for industries like medical devices, defense, and aerospace industries. And where regulation comes in, so certifications are required. Additive manufacturing parts can be certified by a third party to ensure they meet quality standards. And yes, you need standards to follow this kind of a technique, and you need certain certifications by the third parties or the industry volunteers to provide you the certificate by after auditing, testing your equipment, testing your equipment. So everything you need, from the calibration certificate of the machine to the calibration certificate of the method to the regulations that you are following during the manufacturing, to the skill set of the person using that techniques, everything you need to document, and everything you need to get the certification during this kind of a process. Right. So we have third parties such as TUV. It's a German company, conducts independent audits to ensure the part quality meets the standard. So we have multiple other ISOs 13485. We have 52920. We have 15223. Sorry, 15226. We have 60601 for medical devices. These all ISO standards are the standards where you have to refer to manufacture these kind of parts. So I think I am over the limit of the of the time that I have been given by the coordinators. And so last thing is, do you have any questions? Okay, any questions, guys? Anything, anybody? And hope this was not as boring as I thought of. I tried
No,
to.
sir, no, no. This is Dr. Gaurav, and your presentation is good.
Thank you so much, doctor. Okay, and just feel free to reach out to me.
Yeah, I will be reaching out to you.
Definitely, sir, definitely. And thank you so much again, Narinder sir and Gurveet sir, and for inviting me and giving me this opportunity.
Sir, please, one query.
Yes, sir. Yes, definitely.
Please hold.
Yes, sir. Yes, definitely. Yeah, I'm not leaving yet. I have much of a time. Don't
Sir,
worry.
what are the challenges in scoping of additive manufacturing?
See, sir, there are a lot of challenges that I already have discussed during the session, but cost is the biggest challenge that we have right now. And the other one is the mass production that we need in the medical industries, as far as our we uh, increasing the scope of our industry. We need to scope out our manufacturing process also. So that scoping the manufacturing process have challenges regarding cost, regarding availability of the resources, availability of the skills also is a big challenge. Yes, sir.
Chetan, sir, the post processing.
So post processing, I think, is a challenge. But see, testing we have done. I would say we have given a lot of time during the traditional way of manufacturing, that we have understood how to do it. So post testing,
Okay.
post manufacturing is we kind of a know, okay, this is how we're gonna do it. The challenges here is to deal with the mass production, the
Yeah, mass production is a big
big
challenge
challenge. Also the
because it takes a
availability
lot
of,
of time.
yeah, because, and also we don't have resources,
Hmm.
the machine I saw during the exhibition on the YouTube. So they were manufacturing part for BMW, and you say it was a part where our shifting gears is there in the interior of the car. It's just that small part, and for that small part, you need a machine as big as a room,
Hmm.
right? So these kind of challenges are way too much for. But yeah, and advancements are coming. So when I was using this additive manufacturing uh, in like 6 years back, I was having one machine which was taking uh, 2 gram part, and
Hmm.
it was taking, I think, 4 to 5 hours to create the 2 gram part.
Okay, okay.
So advancement has come, and that machines, because cost also comes in factor. Industries are not
Hmm.
as for researchers. You cannot just afford crores of machine just to do the researches. You don't have that
And
accessibility.
it still takes some time.
Yes, it still takes some time.
Mhm.
Okay, I think I would have to leave it. Just
Thank you, sir.
and anything else?
Chetan, sir.
This sir.
Sir, future scope of additive manufacturing.
So future scope is nowadays it's additive manufacturing is in a very hype medical industry, automotive industry, because complexity in the parts has come in the chapter. Everybody needs precise parts, quality parts, complex geometries. So I think it's coming 10 years is a boom for additive manufacturing because industries has already incorporated the manufacturing process in their the current portfolios. So I think it's definitely going to be a game changer.
Sir, I have a query.
Yes, sir.
Sir, can we make implants with the help of this additive manufacturing? Is possible?
Yes, sir. It's very like people like industries are using. So as I told in the starting of the in the presentation, I was working for Boston Scientific and the Striker, like not really with the company, but uh, just give me a second, sir. Just give me a second. I'm really sorry I had to take that call. So the question was regarding the implants. So I would like to show you guys something regarding the implants. So like just wanted to show how advancement has come up in the medical industry. And advancement in the additive manufacturing. So this is a striker. This company deals with medical devices, and as sir asked about the implants, so they work majorly on the implants. So they have a portfolio where they have implants for the orthopedics, right? And just and that picture that I previously had, just I would take just 1 minute. See, I always get very excited about whenever I discuss about medical industry. Just because sir asked this question, so I got curious because I have also worked on this kind of thing. You see these implants, and also you must have seen one picture that I was showing at the like very initial slides of mine. So these are all manufactured by the additive manufacturing process. So you won't believe human being has advanced a lot, and they have used this kind of advanced technique to this extent that in our body itself, like our bones are replacing these metal implants which are basically manufactured by the additive manufacturing. And it's very useful because see, this is very complex design. And also, like I would have bone structure as my own, somebody would have bone structure as his own. So the shape, the size, it varies a lot. So additive manufacturing comes and benefit a lot during this technique, during like due to requiring for the requirement of this application. So implants has a lot more to deal with the additive manufacturing, sir. Okay. And
Chetanji, thanks for this wonderful presentation. So I'm
definitely,
really thankful for to you sparing the precious time from your busy schedule. My question is, as you are saying that this is in a very good applicable in the medical industry. So is there any cost factor right now which can impact that? If this is such we can say that a miracle thing has been happened as per your statements, this will be an very beneficial for the mankind. If there is any some issue related to the bones, it will be maybe helpful. So what about the cost factors which affects that, sir?
so definitely, sir. Right now, I would say, uh, if you'll go and get, like, if somebody would go and get an implant, in the hospital, so it's gonna cost a lot. How that and why that cost come from is because of the processes that currently we are using in the manufacturing of the implant, right? So cost is a big challenge for us right now to deal with. And why the costing is, as I said, testing equipment that we need, alloys that alloys as a material that we need in the implants, manufacturing technique that we are using, powder bed fusion like techniques that we are using right now. These type of technique itself is creating cost in the overall process. So this is a thing that we have to encounter in the coming future. But advancements are coming now. If you go to Striker, if you would have gone to Striker or the hospital which is using Striker's product or Boston Scientific's product as an implant, they would cost you, let's say for example, 1 lakh rupees. But now after
Okay.
years, it's now costing 80,000. So that 20,000 of reduction has been done because the popularity of implants has been increased, the production of the implant has been increased. Why would a company invest in the low production? They require more production. That's why the cost is also getting decreased day by day. So it's gonna get decreased coming future. But yeah, challenge is there regarding the cost.
Yeah, thank you. As you said that it presently it may be high, but in the future time with the use of it, if it is in a quantity, more quantity is required, so cost will get lower down. Am I right, see?
Yes, sir. Yes, definitely. We have a question from Upen Kumar Bhatia ji, and he wants to ask that can we scan somebody's bone structure and save for future to retract whenever we need at later stage? No, definitely not. See, you can preserve, like you can preserve the bones of somebody, some human, for testing, for research purpose. But I would personally not say to get it used to save life of others, right? Because a lot of other regulatory challenges that we have, bone marrows that we have, which relies on body to body, human to human. So that's a research which would take more time. But right now, yeah, you can use it definitely for testing. We use it, like medical industry are using it for testing it, for checking what the overall shape of it, what the strength of the bone is, how much strength you required in the implant, what type of bonding you required in the implant. That would be tested by the bone structure, right? Also, sir has asked, discuss about the post-processing and implants, also specific to dental implants, what type of processing would need to and how would be cost involved. Really sorry about dental implants. I don't have much idea about it, but yeah, processes are definitely same for any of the implant. If I'll talk about the hip implant or ball joint implant, so the post processing are eventually are the same. So you don't have much different processes, but yeah, cost effect involves on the size of the implant also. So dental implants are less to be used and are smaller in size, not less in the use, but are smaller in size as compared to the other body part implants, for example, hip implant, which needs more process, which need more complex post-processing process. So definitely cost will be more. So cost is a big factor. Like I can talk about cost on like hours for this additive manufacturing, because it's very new. Traditional way that we were dealing in the industry previously, it's been years that we were like, it's been decades and more than thousands of years that we were using it. But now this new technique that has been developed, we will have some time, it will take some time to get in that place, and we can, at that time we can compare with the traditional manufacturing process, and we'll say, hey, I don't need the traditional way, I would go with the additive manufacturing way, because it's more precise. You can, it's having more benefit than the traditional way, not with respect to the cost, but other benefits also. Okay, Harman sir, I just wanted to ask one question, sir, please. I think somebody raised his hand. Arman Singh raised his hand, I guess. Okay. Anybody has more questions other than this?
Chetan sir, I want to know that in your industry, are you using this 3D printing or 4D printing?
Yes, sir. So I'm working with Johnson Johnson's right now. See, I'm in the payroll of Tata Consultancy Services. Tata Consultancy Services provides a consultancy to every industry, either in aerospace industry or it's in medical device industry. So I'm in the life science domain, though I have the experience of automotive also. But currently, I'm like primarily dealing with the automotive industry, and my client is Johnson Johnson's, and I have the child company called Boston Scientific, if you'll search about it. So they manufacture catheters, and catheters are being manufactured a lot by additive manufacturing because of their complex design, because of their small orifices they needed, because of their the connections or the inflators and the balloons in the catheters that they use it. So I have experience with like, though I don't have personal experience because I virtually work with Johnson Johnson's during these days because the company is in the US. But yes, we are using it. But in the first industry, which is Padmini VNA, as I said, we used to deal with that 3D printer, which we were very frustrated about because it was taking a lot of time at that time, and like we have to manufacture 2 gram 3 gram of part, and we have to wait like hours for getting it manufactured and printed.
Thank you, sir. Participants, any question from your side? If you have any query, you can ask to Chetan sir. I think there is no query. Mr. Chetan, I would very like thankful to you for this wonderful session, and you have explained very clearly about this 3D printing, and I'm very thankful to you, sir.
Thank you so much, sir, for giving this opportunity. And again, feel free to reach out to me anytime, and I would definitely gonna help you out in any of your questions or the queries regarding the same. Thank you so much, sir. Thank you very much.
Definitely, sir. Thank you. Thank you very much. Thank you. You can leave, sir. Thank you.
Thank you.